السلام عليكم ورحمة الله وبركاته. Today we will speak about nuclear physics. First, we will start with nuclear and atom structure. The atom consists of nucleus. This nucleus surrounded by the electron which rotate in its orbital. The nucleus consists of elementary particles, protons and neutrons, which are known as nucleons. Protons have a positive charge of the same magnitude of the mass of the electron, and its rest mass is about 1,836 times the mass of the electron. The neutron is electrically neutral, whose mass is almost equal to the mass of proton. The element symbol can be written as shown. Here X represents the chemical symbol. Z is the Z number, which is equal to the number of protons or electrons. A is the mass number, which is equal to the number of protons and neutrons. The number of neutrons equal A number minus Z number. For example, Cl1735. The number of protons is 17, and the number of neutrons equal to 35 minus 17, which is equal to 18. There are three kinds of atoms. The first kind, isotopes. The second one is isobars, and the third is isotones. Isotopes are the atoms of the same element having the same atomic number Z, but with different mass number A, like hydrogen atom, or the isotopes of hydrogen, H11, H12, and H13. The three atoms have the same Z number, but different mass number because they have different number of neutrons. Isobars are atoms of different elements having same mass number, but different Z number, like oxygen 816 and nitrogen 716. These atoms have the same mass number, but different Z number. The last one is isotones. The isotones are atoms of different elements having the same number of neutrons, but different Z number and mass number, like carbon 614 and oxygen 816. These two atoms have the different number of protons, different mass number, but the same number of neutrons. The heavy nuclei that contain a large number of protons inside the nucleus is unstable nuclei. If the number of protons inside the nucleus is very large, this nucleus is unstable nuclei. To be stable, the nucleus may emit alpha particle or beta particle or gamma rays. So we will speak first about alpha decay. A heavy nuclei like uranium can emit alpha decay. When it's emit alpha decay, the mass number decrease by 4 and Z number decrease by 2. So U92 to 138 converted to TH 90 to 134 and alpha particle. The alpha particle have the same mass of helium atom. The properties of alpha particle. The alpha particle are composite. A particle consists of 2 protons and 2 neutrons. Alpha particle was the first nuclear radiation to be discovered. Beta particle and gamma rays were identified soon after. Alpha particles are relatively slow and heavy compared with other forms of nuclear radiation. The particles travel at 5 to 7% of the speed of light. Alpha particles are unable to penetrate very far through a matter and are brought to rest by a few centimeters of air or less than a tenth of a millimeter of biological tissues. Beta decay. The basic processes in beta decay are converting a neutron into protons and an electron, or proton into neutron and a positron. Here, when the neutron can convert to proton and give electron, which is beta minus, or proton converted to neutron and give positron, which is beta positive beta. Like here, C614 can convert to N714 and beta minus or electron. Here, N712 can convert to C612 and positron. The properties of beta particle. Beta particles are high energy, high speed electron or positron that can eject it from the nucleus. Beta particles has the same mass, has the same mass of electron, and they have a mass which is half of 1,000 of the mass of proton. The light mass means that they lose energy quickly through interaction with matter. Beta particles are much less ionizing than alpha particles and generally does less damage for a given amount of energy. They typically have a range of tens of centimeters in air and a few millimeters in material. Gamma decay. In gamma decay, no change in atomic and mass number. Here, C612, but it's excited atom. It can be stable and giving gamma rays. The properties of gamma rays. Gamma rays are electromagnetic wave of a short wavelength and a high frequency. The wavelengths range from 0.005 angstrom to 0.5 angstrom. Gamma rays travel with the velocity of light. Gamma rays produce a fluorescence effect of an photographic plate. Gamma rays ionize a gas that travels through, but ionization produced is very small. Gamma rays are highly penetrating ray, and they can even penetrate than alpha and beta particles. For instance, can even pass through 30 centimeters thick iron. Thank you very much.